Assalamu alaikum everyone. Today the topic is Introduction to Matrices. What is matrices? Matrices is a set of arranged in rows and columns and system as rectangular array. What is rectangular array? Rectangular array means these two system of scale A3, A4, A5. This is known as the elements or entities of matrices. So as a whole, I am describing the matrices, this A, B, C, D, whatever you use, but always used A, B, C as a capital letter. A, B, C is the matrix representation. Then this is the matrix notation, and A1, A2, A3, A21, these are the elements or entities. This must be represented by A11 equals to 1, 2, 3, something else. So this is the general representation of matrices. Now what is column and row of a matrix? Column is the vertical. This is the vertical way is the entities present in vertical way is known as column. The entities present in horizontal way is known as row. In this case 6, 5, 0, 10, 3, 2. These are the two columns, and 6, 10, 5, 3, 0, 2 are the three rows. So this the dimension, if I am writing 3 cross 2, 3 mean number of rows and 2 mean number of column. I will discuss later. Now the order of matrices. The order of matrices solely depends on number of rows and number of columns. By conversion, rows are listed first. First we write rows and then column. For example, in this case, we have 1 and 2 column and 1, 2, 3 rows. So I write row into column. So how many rows? 1, 2, 3. 3 into 2. 3 into 2 is the order of this matrix. Equal matrix. Equal matrix must have following three conditions. Each matrix has same number of rows. Each matrix has same number of columns, and corresponding entities within each matrix must be same. For example, matrix A contains 1, 2, 3, 4, 5, 6, 7, 8. It's contain 3 cross 3 matrix. Now this 1, 2, 3, 4, 5, 6, 7, 8. It's 3 cross 3. Now has same number of rows and same number of columns. And also the entities, the number presented in this rectangular array are also the same. So this matrix A equals to matrix B. This is known as equal of a matrix. Then rectangle and square matrix. Rectangle matrix, if the number of rows is not equal to number of columns. For example, in this case, the column is 1 and the rows are 2. So the order will be 2 cross 1. So this is not a square matrix, it's a rectangular matrix. In this case, the column is 1, 2, 3 and row are 1, 2. So the order is 2 cross 3. In this case, 1, 2, 3. These are 3 rows and 2 columns. So the order is 3 cross 2. And in case of square matrix, the number of rows must be equal to number of columns. 1 minus 6, 2 column, 2 row. So the order is 2 cross 2. And in this case, 3 rows and 3 columns. The order is 3 cross 3. So in square matrix, it must contain 1 cross 1, 2 cross 2, 3 cross 3. But the order remains same with respect to number of rows and number of columns. So in square matrices, number of rows must be equal to number of columns. Now null or zero matrix. If the entities in the brackets are having 0, 0, this is known as null or zero matrix. For example, this is a rectangular matrix containing 0, 0, 0, 0, and this is a square matrix containing 0. So a matrix containing 0 element is known as null or zero matrix. Now the important parameters. Transpose of a matrix. What is transpose? Transpose of a matrix is the interchanging of rows into columns. For example, in this case, 3, 4, 2, 1. This is the row. This is the row 3, 4. And when I converted this into the transpose of matrix, this row must be converted into column. 3, 4, row 1 is converted into 3, 4, column 1. 2, 1, row 1 is converted into 2, 1, column 1. So by interchanging number of rows into columns, this representation is known as transpose of a matrix. Now negative of a matrix. The negative of a matrix is simply the changing of sign. For example, if this is a matrix A, B, C, D, and I am changing the minus A, minus B, minus C, minus C, minus D. So this is the negative of matrix. Where there is a negative sign, this must be replaced by a positive sign in negative of matrix. For example, in this case, in a case minus A minus B C D, so the negative of matrix will be A B minus C minus D. Now symmetric and skew symmetric. Symmetric means this summation must be same. For example, if I have a matrix A, then its transpose must be equals to that matrix. For example, I have a matrix 1, 2, 3, 4, 5, 6, 7, 8. Example, uh, if I am taking transpose 1, 2, 3, this is the row 1. I am converted into column 1, 2, 3. 2 4 5 2 4 5 3 5 8 3 5 8 by taking the transpose. Now taking the elements 1 2 3 1 2 3 2 4 5, the element position is same. This is known as symmetric matrix. So in symmetric matrix, the matrix is equals to the transpose of its matrix. In case of skew matrix, the negative of a matrix is equals to transpose. For example, a matrix 0 3 4 minus 3 0 7 minus 4 minus 7 0 0 minus 3 minus 4 3 0 minus 7 4 7 0. This is the matrix transpose. Now looking at the sign, there is minus sign minus 4. By converting into minus 4 minus 3, this is the 3, it's converted into minus 3. This minus 7 is converted into plus 4, this minus 4 and minus 7. So this negative of matrix is equals to its transpose. It's known as skew symmetric. Now diagonal matrix. Diagonal, for example, I am talking about principal diagonal elements. The principal diagonal element members are this element, those are in blue, is known as principal diagonal elements 1 2 3. In case of a diagonal matrix, the diagonal entities must not be 0. All the diagonal entities must not be 0. 1 2 3 1 0 0 is also a diagonal matrix. 0 1 0 is also a diagonal matrix. 0 0 1 is also a diagonal matrix. At least one element must not be 0. Scalar matrix. Scalar matrix is basically the modified form or a classified form of a diagonal matrix. In this matrix, the principal diagonal matrix members having same constant values. For example, 3 3 2 2 5 5 5 1 1 1 1 1 1 is a special case. It's known as identity of matrix. Is the diagonal elements contains only one. In case 2 cross 2 3 cross 3, it contains only one. So this is known as identity of a matrix. Now the operations. There are multiple operations, but we are starting from a simpler one, that's addition of a matrix. In addition, the same element, for example, this is a matrix. This is the A11, A12, A13, A21, A22, A23, A31, A32, A33. For example, and same A11, A12, A13. This A11 is sum with this A11. This A22 must be sum with A22. There's three sum with 3. Now 1 plus 9. This is the summation. 2 plus 8, 3 plus 7, 4 plus 6, 5 plus 5, 6 plus 4, 7 plus 3, 8 plus 2, 9 plus 1. So after this, sum all 1 plus 9, 10, and concluding this is known as the addition of a matrix. And in the next case, the negative only differ with a sign. All those 1 1 1 A11 minus A11. So 1 minus 9, 2 minus 8, 3 minus 7, 4 minus 6, 5 minus 5, 6 minus 4, 7 minus 3, 8 minus 2, 9 minus 1. So these are the simpler operations, addition and subtraction. Now the most complicated in the matrices is the multiplication of matrix. Two conditions must be satisfied. The number of columns of matrix 1. In this case, number of columns are 1 2 must be equal to number of rows of the second column. In this case, 1 2. So it's contain 2 rows and 2 columns. It's contain also 2 rows and 2 columns. So the first point must be is applied. Now the second is, and the result will have the same number of rows after the multiplication. This is the A, B, and this is C matrix. A matrix is the order 2 cross 2, B matrix 2 cross 2. Then the C matrix, the after multiplication also have the order 2 cross 2. Determinant of a matrix. The determinant of a matrix is generally a addition or a multiplication, then converting a sign. So this is the whole process is known as the determinant. So while taking determinant, this sign is the special sign or notation sign for determinant. Now A, B, C, D. This matrix sign is also absolute sign converted to absolute sign. Now what for determinant approximation? Now A multiplied by D, then a negative sign of formula, then B multiplied by C. Then this is AD minus BC. This is known as the determinant of a matrix in case of 2 cross 2. When we have 3 cross 3 matrix, for example A, B, C, D, E, F, G, H, I, then taking A as a common, then cancelling its same row and column A, D, G, and B, C, A, B, C. Then the remaining elements E, H, F, I is the matrix one. Then the second B column and then the row must not be included, and the elements must contain D, G, F, I, D, G, F, I. Then C column and row must be neglected, and D, G, E, H. Now the another important conversion, that the first element must contain positive, then negative, then positive. So A must be positive, B must be negative, and then C. So then same EH minus FH, DI minus FG, and DH minus EG. Then also simplified, multiplied by A, B, and C, and we then make a reasonable answers. So this is the method to find the 3 cross 2, 3 cross 3 matrices. Now singular and non-singular matrix. For conversion, a singular matrix is a matrix with a determinant 0. In case 1, 2, 2, 1 is a matrix A. By multiplying 1 by 2, 2, and minus 2. 2 minus 2 equals to 0. So this is a singular matrix. All those matrices whose determinants are not 0 are known as non-singular matrix. In this case, 1 multiplied by 2 and 3 minus 2, the answer is 4, which is not equal to 0. So this is the non-singular matrix. The last topic of this lecture is the adjoint of a matrix. Adjoint or adjoint of a square matrix is the transpose of its cofactor. What is the transpose of its cofactor? For example, this is the matrix A, minus 3, 6, 4, 2, and this is the adjoint. This is the adjoint. How to find adjoint? This is by taking two main points. By taking 2 points. One is by converting the diagonal entities. For example, this 2 is A11, and this minus 3 is converted into A22. So by interchanging the position of diagonal matrix and the other elements, by changing the sign of the other elements, minus 4 and minus 6, this is known as the adjoint of a matrix. Adjoint of a matrix.
Bus. We can stop recording.